Good afternoon, everyone. My name is Luis Vidal.
And I'm John Mern.
We're co-founders of Entheleon Technologies, and today we want to talk to you about video compression. Before we do that, we want to talk about the team a little more.
So I'm co-founder of Entheleon. I was just until recently a PhD candidate in Stanford's Intelligent Systems Lab. And before that, I was a UAV systems architect at Boeing Phantom Works.
I also got my start at the Boeing company. Most recently, I graduated with my MBA from HBS. And Mark, who couldn't be here with us today, we hired a few months ago, is also a PhD out at Stanford. Now, coming from the aerospace industry, we were aware of a very unique and interesting problem, and that is that the proliferation and use of these surveillance UAVs has skyrocketed the demand for real-time video across battlefield networks. That's a problem because the tactical communication systems that these people use has not kept up with that demand. So in effect, what ends up happening is you compete with other types of communication that's going across the network, and video feeds drop. Now, this is a huge and serious problem. We've spoken to a lot of operators, both in our professional and personal lives, and they've all told us the same thing, that losing intel that you need to make a decision in the field is incredibly problematic. Best case scenario, you compromise the mission. Worst case scenario, lives can be compromised. So we thought we could do something better.
So our solution to this is to develop a new type of video compression codec. Now, before I talk about what we do differently and how our codec is so great, I'll explain what a codec actually is. So without realizing it, most of us use codecs every single day. A codec's job is to compress the video frames in a video file, which on their own are way too large to transmit or store effectively, into a smaller, more manageable size, and then when it's time to view that video, to decompress it back into a video space. And while this plays a critical role in all video transmission, the innovation in the space has stagnated over the past years. All of the recent codec standards to date, H.264, 265, AV1, rely on the same basic techniques that have existed for nearly 25 years. The innovation has focused on expanding these techniques in order to take advantage of the increased compute power. As a result, we see the computational complexity march up, while the improvements in compressive efficiency only continue incrementally. Now, we developed a technique to help us jump off that curve. And the way we did that was by applying state-of-the-art machine learning and computer vision techniques to develop an entirely new compression method that completely departs from prior methods. We use something called a convolutional neural network in both our encoder and decoder to create a system that can intelligently decide how to optimally encode streams of videos in real time. The end result is a system that is 90% more efficient than the leading commercial standard out today, H.264. So we're going to show you a demo. What you're seeing on the left here is a video file compressed with our codec, and on the right one compressed at the same data rate but using H.265, which is the most advanced system you can use today. You can see from the still image there's a complete loss in texture in the model ship shown here, as well as if we were playing the video, you'd see motion artifacts generated. If you're a keen observer, you'll see that we compressed this 1080p video to 94 kilobits per second. That's about a third of what it takes to stream high-quality audio today. Okay.
Right. So a lot of you are thinking, that's great, guys. You've got acute technology that you can sell to a niche industry that you can't sell to because it's in the DoD. And we would agree with you for the most part. That's why we spent the last several months here at the Underscore program understanding where our commercial value proposition is really the strongest. And we found a variety of players that compete on the basis of the quality of content that they provide and the cost that it takes them to deliver that quality. So people like satellite backhaul providers that have told us that our codec can seriously differentiate their products for their customers, all the way to hardware, consumer hardware manufacturers that have told us that our codec is, one, blows everything that they've seen out of the water, and two, can dramatically accelerate the onset of their 4K product line. So once you move outside of just defense and you look at satellite backhaul, video streaming, teleconferencing, et cetera, the market size is about $2.7 billion, which is what is spent today in codec licensing and royalties. This is our roadmap, how we get there. We have been awarded a couple Air Force contracts that we're executing on now. We'll be deploying some demo codecs to about 12 or 13 commercial customers that have requested them later this summer, after which we'll be targeting the satellite backhaul business, with the end goal being to be deployed directly onto consumer hardware devices like phones, smart TVs, Xboxes, et cetera. And the market opportunity grows with each of those. What we learned at the program, having great technology doesn't really mean you have a great business model. And translating technological performance to value proposition is actually quite challenging and extraordinarily important. And then one of the biggest things that we found valuable was using the minimum viable segment framework to really down select and prioritize the people that we target on the commercial side. In terms of our ask, we are raising. If you're interested in participating in a pre-seed round, we're hiring. If you are or know of embedded engineers and AI engineers that would be interested. And we're also doing customer development still. So if you find yourself in this space and would like to talk to us, please come and ask. Thanks a lot.